Now let's go to question number 6 in the tutorial. These type of graphs are a bit different from the graphs that we have been drawing all this time. In these type of partial implication graphs, we only draw the necessary branches and only the necessary variables which are being required as per the question. So for example, in question number 6, they say they have given a set of clauses from C1 to C6, and they say that the question assumes P1 to be true at decision level 4. So we don't know what happened in decision level 1, 2, and 3. We just know that at 4, P3 was true. So we are going to draw that, and we're not going to bother about what happened before that. And then they also say that the solver is now at level 6 and makes P3 to be true. The notation P1 at 4 means P1 is true. P1 equals true at 4 is the same thing. These two are the same. So if P1 was false at 4, that will be symbolized by negation P1 at 4. Let's take down our expressions first because it's easy once we take them down. Okay, so these are the clauses we have. So they have given us that P1 is true at decision level 4. So in this type of graphs, let's follow an easy format. Let's say P1 at 4. So this symbolizes the node, just like here we drew circles around it. Here we draw a colored circle. So P1 is true at 4, decision level 4. So now when P1 is true, what will happen? This gets cancelled. This is true. That's it. Okay, so that's all that happens. So now who can be easily assigned a truth value? That is clause number 1, because we have to only check the value of P2. So when P1 is true at decision level 4, who will be directly impacted? C1 will be directly impacted. I'll put C's over here. Okay, so C1 will be directly impacted. So to make C1 true, in the next node, what we have to do is make P2 true at 4. P2 is true at 4. Okay, now C1 is also true. Now when P2 is true, this cancels. There are no other impacts of P2 to these clauses. So now since we are being given a decision at level 6, let's use that also. We have been given that P3 is true at decision level 6. Let's use that because we have been given those two. We have been given about P1 and P3. So if P3 is true, what will happen is this gets cancelled. Okay, that's all that happens. But we can get a direct impact to clause number 2 by assigning a value to P4. So let's do that. So if we look at clause number C2 and assign negation P4 at decision level 6, C2 will be true. This will be true. So negation P4 at 6 means P4 is false at decision level 6. In that case, C2 will be true. So if that is so, this gets cancelled. Okay, now we have to talk about P5. Okay, so when we look at the fifth clause, C5, we'll say P5 is true at decision level 6. When P5 is true at 6, this is true. This gets cancelled. This also gets cancelled. And you see that C3 also has P5. C3 also has C5. C3 had P2. So from here, we can connect to P5 using C3 because C3 has P2 and P5 both. So when we talk about C3, When P5 is true, this gets cancelled. And what's remaining is P6. Since we have only P6 left, let's say in this node that P6 is true at decision level 6. When it is true, C4 will be true. This is true. But what happens is there's direct impact on C3. C3 will not be true. It will be false because C3 needs P6 to be false. Here, as you can see, we have a conflict between the two assignments for P6. So there's a conflict. So when there's a conflict, what do? As we usually do, we backtrack. We backtrack to the decision level, which is above the place where we had the conflict. In this case, it will be state 4, decision level 4 rather, because we don't know what's happening in the decision level 5, but what we are given are decision level 4 and decision level 6. So since the conflict occurs at 6, what we do is we backtrack to 4 and change the value, change the decision that we took at 4 to the negation of that value. For example, if we took P1 to be true at level 4, now we make P1 false and see if we can reach a satisfiable model. So that is what we do in the second step of the implication graph. And at the same time, before we start drawing the second graph, we have to add a new clause, a 7th clause to our set of clauses, where we join the negations of the previous two decisions we took and make a new clause. For example, in the previous graph, we said P1 is true and P3 is also true, but here we did not get the answer, we got a conflict. So what we do is we introduce a new clause with the negation of these two values. So say, for example, if the previous decisions were where P1 was false and P3 was true, in that case, our 7th clause will be P1 or negation P3. So we introduce this new clause and then start drawing the new implication graph for the new set of clauses. So here we have the decisions. The new decisions are P1 is false at the decision level 4 and P3 is true at decision level 6. So I'll start drawing with P3 at 6. So if P3 is true, then I have to cancel this off. This gets cancelled too. So I'll take the impact of C2. So to make C2 true, I have to make P4 false. When P4 is false, this will be true. I have to cancel this off. And then C6 has an impact from P4. At the same time, it has an impact from P1 as well. So what we can do is, let's take the value of P1. Now it is false. Let's take that impact and connect it with P4 over here. This is C6. So since P4 is false, we can say that this is true. Okay. Now let's go ahead and make C5 true by applying P5 to be true. If that is true, then I have to cancel this off and this gets cancelled too. Then let's see what will happen to C4. To make C4 true, I'll have to make P6 true. When P6 is true, I have to cancel this off. When I made P1 false at decision level 4, since here I have negation P1, here also I have negation P1, so this became true. At the same time, this also becomes true. So now what I'm left with is C3. So to make C3 true, let's say negation P2 at 6. So this will make C3 also true. So all the clauses are true. So this is a satisfiable set of clauses. So the conjunction is satisfiable. In the second implication graph, we did not make any conflicts. After making the change to the decision level 4, we did not meet any conflicts. We got a satisfiable model where P1 is false, P3 is true, P4 is false, P5 true, P6 true, P2 false. So this is a satisfiable model.